There are three major steps in an organized troubleshooting process. The first step involves analyzing and predicting normal operations. You can gain an understanding of the normal operations from the documentation, configuration of the network, and the output of specific commands. For example, consider a LAN of two PCs interconnected together. Normally, the two PCs should be able to ping each other. One of them is unable to ping the other. You can examine the documentation and identify the normal path of traffic between these two PCs. The second step is problem isolation. You can identify the problem and the network area where the problem occurs by tracing the path of a frame across the network based on the documentation and configuration of the network and the output of specific commands. To isolate the problem further, you can examine the switch MAC tables and identify the interface where the traffic failure occurs. The final step is root cause analysis. You can do this by examining all the causes of the problem that you have isolated in the previous step. With this analysis, you can also identify the action that will fix the problem. Now that we know that the switch interface failure caused the traffic failure, we need to examine all the reasons for switch failure and identify a single cause for that failure. Now, let's look at an example of a network with a problem. We'll try to troubleshoot the problem. Troubleshooting on LANs mostly begins with user experience. Then the analysis moves into how Layer 3 is functioning. In the small LAN setup that you see here, imagine that PC 1 fails to connect with the web server. How do we analyze this problem? First, we'll determine whether PC 1 can resolve the host name into the correct IP address. If it can, we'll analyze if there is a problem with Layer 3 by looking at the routing steps involved. So Layer 3 is functioning properly, and we can rule out a problem there. The next step is to identify if there is a problem at Layers 1 or 2. If in Layer 3 analysis, we find that PC 1 cannot send a packet to its default gateway, R1, we can further examine the MAC addresses of PC 1 on R1's LAN interface, the switch interface used on SW1 and SW2, the interface status of each interface, and the expected forwarding behavior of a frame sent by PC1 to R1 as the destination MAC address. By conducting a step-by-step and thorough investigation as discussed here, you can identify the root cause of the problem. After identifying the cause, you can troubleshoot the problem.